folks. This is chapter 11, part 3 of your notes. This will be the final part. It'll be pretty quick, so we're going to get right to it. We ended up talking about types of chemical compounds. So now we're going to talk about rates of change, or in other words, things that can affect how fast or slow a reaction takes place. All right, and there's a couple different factors. Let's talk about them. First is temperature. Okay, so what do you think temperature does? Do you think it would, if we raise the temperature, what would happen to the reaction? Or if we lower the temperature, what would happen to the reaction? And the answer is kind of common sense, right? If we increase the temperature, those molecules and those particles are going to move around more and move more quickly, bumping into each other, increasing the speed of the reaction. So as temperature goes up, so does the reaction. As temperature goes down, then so does the speed of the reaction. So it's going to slow down the reaction. So if you ever wanted to slow down a reaction, keep it cool. All right. Next one is surface area, which is probably you don't really think about that often. But the more surface area, or the more exposed solid, the faster the reaction. But you might be thinking, how can we increase the surface area? Well, we can increase the surface area by making the particles smaller or cutting it into more pieces. So my example is a potato. Now, when you cook potatoes, like if you want to make mashed potatoes, you don't usually just throw the whole potato right into the oven, right? Or right into the boiling water. A lot of times you peel them and then you cut them. So if you cut the potatoes, they're going to boil or they're going to cook through a lot more quickly because look at this. Now, instead of just having one surface, all this inside surface area is available to be in contact with the water, meaning a faster cook time. So if you ever wanted to cook your mashed potatoes faster, just cut them into smaller pieces. And so that's surface area. We're talking about a compound or something. Usually we crush them. So think about table salt in crystal form. If we wanted that to dissolve more quickly, we could crush it into like more of a powder. So the smaller, the more the grains, the more surface area we have, the more places that it has to come in contact with. Then there's concentration. So think about something that's concentrated means there's a lot of stuff there. So if you think about, oh, that sugary drink is very concentrated. It means there's a lot of sugar in there. There's a lot of something. So the more concentrated the solution, the faster the reaction. So if you increase the amount of stuff in it, the more it's going to work. My example here, washing dishes with enough soap. If you don't use enough soap, the high concentration of soap, then you probably won't get all your dishes clean. Okay, the bubbles run out and you can't do it. So it has to be a high concentration in order for that to work. So that's the first three. Moving on to the fourth is catalysts and inhibitors. So these are two new vocabulary words, so let's define them. A catalyst is something you add to speed up a reaction. It is not a reactant or a product. Something like this, think about lighting a match to light a candle. Okay, you're adding a catalyst. Without it, it probably, maybe one day it would start, but it wouldn't start on its own, right? It speeds up the reaction. So heat is a common catalyst we use to speed up reactions. There's plenty of catalysts inside our bodies to start the digestion process, and we'll talk more about those in our class. And then an inhibitor is something you add to slow down a reaction. So you might want to inhibit, means to stop or prevent. To stop a reaction, you'd add an inhibitor, something that would interact with the compounds they couldn't react. So those are the four things that can affect rate. A few more vocabulary terms that we need. Other things to know about change. Some reactions are reversible. Okay, and this word is equilibrium. For example, if we think of an unopened bottle of soda, okay, like Coke or Pepsi, the CO2 is dissolved in the liquid, and when you open it, you hear that sound, right? That's the releasing of the gas. When you open that cap, you disturb the equilibrium. Okay, so when that soda is closed, it's in an equilibrium state. And again, equilibriums happen when the reaction is balanced or in a constant state. This means no apparent change is happening or the change is equal. And in the case of a soda, the gas that's inside the liquid is escaping in small amounts into the air above this. So there's some gas dissolved inside here and then some gas up here, okay? So that is in a constant state. Next part, CO2, and here's an example. CO2 that's aqueous, meaning dissolved in water, AQ, aqueous means dissolved in water, and CO2 in its gaseous form. So the CO2 would be gas up here, and aqueous or dissolved in the liquid down here. And when you open it, you disturb that equilibrium. All right, last bit of our notes then. Two more terms we need to know. Sometimes compounds can be endothermic or exothermic, and the prefix here, endo and exo, are going to be the important part. So an endothermic reaction uses heat from its surroundings in order to run the reaction. So they feel cold because it steals the heat from its surroundings, so that like if there's a beaker in front of us, it's an endothermic, it would feel cold to the touch. The next one, exothermic reactions produce heat, so they feel hot to the touch. Okay, so we'll take a look at a couple of those in class so you can see what an endo and exothermic reaction is like. All right, that's it for our notes. I told you it would be quick. You also have a homework quiz to complete today, so please don't forget to do that on Schoology. All right, thanks guys.